Today, our topic clippers and diode switching time. So, different types of clippers. One is positive series clipper, negative series clipper, parallel positive clippers, parallel negative clippers, clipping of both of cycles, and provide bias diode clipping and negative bias diode clipping. So positive series clipper or series positive clippers. So first of all, what do you mean by clipper? Clipper means some unwanted portion we want to clip or cut. So clipper circuits we also called as limiters. Clipper circuits we also called as limiters. Limiters are voltage limiters. We want to clip or limit some level of voltage. For that purpose we are using clippers. Okay, so clippers are designed by using diode. Clippers are used for voltage limiter circuits. So these clippers are designed by using PN junction diodes. So we will see one by one. So first one is series negative clipper. So the name suggests negative clipper. So negative portion is clipped. Negative portion is clip or cut. Negative portion is clip or cut. See in this figure you see there is no negative portion. So it is clipped. So how it happens I will explain. So this is diode. We know that anode and cathode. Anode is a positive, cathode is a minus means negative. So this is the load across output side. This is the load means RL. So input. So VI is the input. So VI is the input means we are giving the input here. So this is the input. So whenever input is given, so this one is positive half, this one is negative half. The positive half, this terminal is plus and this terminal is negative. So as intermediate level physics, we know that so positive terminal is given to the anode. What happened? So already anode is a positive. Positive means holes having positive charge. So positive charge and positive charge ripple. Ripple means positive charge ripple means what happened? So these holes are moves towards the junction, and this is also negative. This negative means here electrons are moved towards the junction. That means there is no barrier. Barrier width is very less. So there is a conduction possibility. Because of conduction possibility, this diode is forward bias. Whenever first positive half is applied, diode is forward bias. Forward bias means it is conducting. So current is passing through this. Current is passing through this. Okay. Current is passing through this. What happened? So whenever positive means that positive signal is coming, so rectifying. So whenever negative portion is given, this portion, negative portion is given. So now terminal is this one is negative, this one is positive. So negative terminal is given to the anode terminal. So this already anode means holds positive charge. This one is negative. Both are attracted. So junction width is increases. So finally we can say that it is a reverse bias. Reverse bias means diode will not conduct. Will not conduct means it is a open circuit. It is a open circuit. Okay. So open circuit means it is reverse bias, there is no output. So this is called series negative clipper. Series negative clipper, only negative portion. This portion we don't want. That's why only we want positive portion. For that purpose, we use a negative clipper. Okay. See, I read during the positive off cycle diode, consider as a ideal diode, appears the forward bias and conducts such that entire positive off cycle of input appears across the resistor connected in a parallel as the output waveform. Okay. During the negative off cycle of the diode is reverse bias, no output appears across the resistor. Thus, it clips the negative cycle of the input waveform and therefore it is called a series negative clipper. So similarly, series positive clipper. Now I want to clip positive portion. I want to clip positive portion. So what is the difference between a previous this circuit and this circuit? Only diode terminals are interchanged. Diode terminals are interchanged. Now I am given it is a positive clipper. So now I am given the signal, input signal. This one is plus, this one is minus. First half means this one is positive, this one is negative. So positive terminal is given to the cathode, means cathode having negative charge. Negative charge, positive charge means attracted. So junction width increases. Now it is reverse bias, means off for positive off cycle. That means there is no output. Output is zero at positive half. Again negative half is given. So this is negative, this is positive, diode is forward bias. So there is a output. So this is series positive clipper. Okay. So parallel positive clipper. So in previous diode is connected in series. Now diode is connected in parallel to the load, parallel to the output. See in previous output, so there is only resistor is the parallel. So diode is series. Here diode is parallel. That's why it is a parallel positive clipper. Parallel positive clipper. So similar to previous one, it is the input is given. So first half diode is forward bias. Forward bias means output will appear across the this load, across the load. We will get this portion because here diode is a not an ideal diode. It is having practical diode means cutting voltage is 0.7. Up to 0.7 only it will conduct. Remaining it will not conduct. Okay. So positive half diode is forward bias. Only we will get this one. So what about negative? Negative is given. So negative is given means, so this is negative, this is positive. This one is negative, this one is positive. So whatever the voltage is there, same voltage will appear at the output side. That's why this wave will come. Even though it is off means open circuit, same voltage. So we know that basic thing. Parallelly voltages are same. So same voltage will appear across the load because it is a off for negative off cycle. Understood? Next, parallel negative clipper. It is similar to previous one, just diodes terminals are changed. So whenever positive is given, what happen? Whenever positive is given, what happen? So this one is positive, so cathode anode both opposite means barrier width increases, it is off, diode is off. So diode is off means whatever the voltage at the input side, same voltage will appear at the output because in a parallel voltages are same. This one negative half, diode is, whenever negative is given, diode is negative negative, so it is forward bias. Forward bias means it conduct. So it is a practical diode means only 0.7 volts cut in voltage it is conducted. That's why this wave is appear like this. Okay. Next, clipping of both off cycles. Clipping of both off cycle means we want to connect both two diodes in parallel to the output. So this one is positive half, this one is negative half. So positive half is given. What happened? This diode is on. This diode is off. Diode is on means up to 0.7 volts it is on, remaining it is off. Similarly at negative side, this is 0.71 volts on, remaining it is off. So output is like this. So biased diode clipping circuit. In a previous we will see only diode. So biasing means we have to give some voltage, extra voltage or reference voltage. So biased diodes is nothing but we are giving a voltage that is called reference voltage or extra voltage to bias the circuit. Our battery, extra battery voltage is connected to the clipping circuit. Okay. To produce the diode clipping circuit for a voltage waveform at different levels, a bias voltage V bias is added in series with the diode. The voltage across the series combination must be greater than the V bias plus zero point 0.7 volts. V bias plus 0.7 volts before the diode becomes sufficiently forwarded bias to conduct. Similarly, if V bias level is set to 4 volts, that is battery, extra battery we are connecting 4 volts, then the sinusoidal voltage at the diode's anode terminal must be greater than the 4 volts, but 4 volts plus battery cut-in diode cut-in voltage, total 4.7 volts, then only diode becomes on or forward bias. So any diode voltage levels above this bias point are clipped off. So we will see, you can observe this, we are adding, this is the extra thing, only bias. So these terminals are similar to, so this is the anode, this one is the cathode. So plus minus, similarly plus minus, same way, polarity. What happen if positive half cycle is given? So diode is forward bias. So forward bias means already we have some voltage here. This voltage plus 0.7 voltage, it will conduct. Remaining it is off. That is the meaning. Okay. Next, negative bias diode clipping. So negative bias diode clipping also, the terminals are similar, bias terminals, this one is the plus, this one is the minus, similarly plus minus. So whenever negative terminal or negative half is given, so this one is on. On means this voltage 0.7 volts, 0.7 volts plus bias voltage, it will on. it will 1. So this portion is bias voltage plus cut-in voltage. We will get this type of wave. Remaining portion is clipped. Now we will see the diode switching times. So diode switching times means while changing the bias condition means on or off, the diode undergoes a transient response. This response of a system to any sudden change from an equilibrium position is called as transient response. So transient response is nothing but it is the sudden change from it is the equilibrium means it is 0. It is suddenly change means like this. So this portion up to this now it is steady state. This portion from 0 to this portion we call it as transient response. The sudden change from forward to reverse and from reverse to forward bias affects the circuit. The time taken to respond to switch sudden changes in the important criteria to define effectiveness of electrical switch. So diode, we know that diode is used as a switch. So we consider these forward bias to reverse bias and reverse bias to forward bias. So circuit may affect on and off condition. So the time taken before the diode recovers, it is called as recovery time. The time taken before the diode recovery its steady state is called as recovery time. So the time interval taken by the diode to switch from reverse bias state to forward bias state is called as forward recovery time. So we have a diode. So diode is switched from reverse whenever diode is at present situation diode is a reverse bias. So whenever we have changed reverse bias to forward bias, so in between there is a time. That time we call it as forward recovery time. Forward recovery time. Similarly, it opposite. Time interval taken by the diode to switch from forward bias state to reverse bias state is called as reverse recovery time. Forward bias state means forward bias to reverse bias is called as reverse recovery time. So you will understood in this. So this is the input voltage. This one is on. This one is negative means it is the stable or steady state. This is the minority carrier concentration. This is high. It is the minority carrier concentration is reduced to 0 or negative level. So here diode current. So this dotted lines we call it as diode response, ideal diode response. So this solid line is the practical diode response. See, this is the on. So in negative side, this is the stable. Up to now, it is the stable. We call it as storage time. So there is no transient in between this point. So this time we call it as storage time. So diode is on condition and also steady state. So storage time. From here, this voltage is changes here. So this time is called transient time or transition time. Okay. This one is a reverse recovery time. Storage time plus transition time, we call it as reverse recovery time. So reverse recovery time is nothing but forward bias. It changes to forward bias to reverse bias. It is called as reverse recovery time. So now storage time means it is in forward bias now. Then it is changes to 0. That means reverse bias. So we call it as reverse recovery time. Forward bias to reverse bias is equal to reverse recovery time. Reverse recovery time. Okay. See, whereas to get on condition from off means that means off to on. It takes less time. Off to on, generally off to on, it takes less time, called as forward recovery time. Reverse recovery time is greater than the forward recovery time. Correct? I will repeat. From on to off, it takes a less time, is called as forward recovery time. So reverse recovery time is greater than forward recovery time. So what do you mean by reverse recovery time? It is from on to off. It is more. Reverse recovery time is more compared to forward recovery time. So a diode works as a better switch if the reverse recovery time is made less. So reverse recovery time means from on to off. The duration of from on to off, that time we call it as reverse recovery time. So that reverse recovery time is uh, is made as less, then only it is better switch. Next is storage time. So storage time is if diode is on only it will happen. If diode is on condition or forward bias, it will happen. See the time period for which the diode remains in the conduction state or forward bias, even in the reverse bias state, it is called as storage time. Next is transition time. The time elapsed in returning back to the state of non-conduction is called as transition time. Steady state reverse bias is called as transition time. So that means returning back to the state of non-conduction. See in this figure, it is the conduction, it is going to the non-conduction state, this period we call it as transition time. This is the definition. Returning back to the state of non-conduction. See, now it is a conduction. It is going to non-conduction, means zero. This state we call it as transition time. Next one is reverse recovery time. The time required for the diode to change from forward bias to reverse bias is called as reverse recovery time. Forward recovery time means it requires the diode to change from reverse bias to forward bias is called as forward recovery time. So reverse recovery time is equal to storage time plus transition time. See, reverse recovery time means storage time plus transition time, both reverse recovery time. Reverse recovery time is nothing but storage time to plus transition time. From on to off, this condition we call it as transition time. Okay, so these are the diode switching times. So these diode switching times may depends on other parameters also. So factors that affects diode switching time. There are few factors that affects the diode switching time, such as diode capacitance. The PN junction diode capacitance changes depending upon the bias condition. See, for example, if PN junction, actually diode switching time depends on the diode capacitance. So in junction, diode capacitance is nothing but junction capacitance. So this junction capacitance is depends on bias voltage. So if bias voltage is more, means what happens? Junction width is reduces. If it is forward bias, means junction width is reduces, then diode switching time may differ. Next one is diode resistance. The resistance of the diode offered by the diode to change its state based on resistance. Diode forward resistance is also affects the diode switching time. Similarly, doping concentration. The level of doping of the diode affects the diode switching time. How? If doping concentration is more, junction width is very less. If junction width is very less means diode capacitance is very less and switching time is more. Understood? Doping. If doping is more means conductivity is more. So the diode switching times also may differ. Next one is depletion width. The narrower the width, the depletion layer, the faster switching will be. So based on depletion width also, if depletion width is very thin, like tunnel diode, switching speed is very high. So it is one of the effect. So diode switching time may vary, depends on this depletion width also. A Zener diode has a narrow depletion region than avalanche diode, which makes the former better switch. So Zener diode is a heavily doped diode, so switching time is more compared to ordinary diode. So these are the different factors that affects the diode switching times. So this is the diode switching time topics. Okay, thank you.